gonna shoot me with a K. Oh, that do it. Hey. Oh.
Greetings, I'm Marcel Thomas, a third-year chemistry major from Chicago, Illinois. I'm going to be writing for my group about logarithmic differentiation.
Greetings and humble salutations. My name is Kiana Jones, a first-year biology pre-med student from Jacksonville, Florida.
Greetings, I am Anjanae Fai, a first-year biology scholar from Wesley Chapel, Florida.
And we are both your researchers.
Greetings, I am Corey Ritchie, a second-year civil engineering student from Kissimmee, Florida, and I am the producer.
Alright, so I'm going to be teaching you guys a little bit about logarithmic differentiation. It's going to be a great way to differentiate certain functions. And the way it helps us is that it's able to prevent us, mathematicians like yourself, from having to use the product rule or multiplying the entire function out and then having to differentiate. Such a tedious process. So I'm going to teach you guys a few different properties. Start off with the product property. We notice that log base b of the function m multiplied by n is going to be equal to log base b, m plus the log base b, n. And we notice that when we multiply, we're going to have a plus sign in between the separation of m and n. Versus in our quotient rule, you know that we're going to divide m and n, and notice that we subtract. So you can remember that in the quotient rule, we're going to divide and subtract. In the product rule, we're going to multiply and add. In the power rule, this is similar to the power rule that we've been doing, so don't let it phase you. We're going to have log base b, m to the power of n, and we know that the power is going to come in front of the entire function, and the rest of everything stays the same. And logarithmic functions, notice that they're the exact same as our natural log functions. You guys can see that? Written in a different color so you guys can see very easily.
Okay, so now that you learned what logarithmic differentiation is, now you're going to figure out how to use it. So how do you use logarithmic differentiation? You're going to look at your function, and you're going to take the natural log of both sides of the function. After you do that, you're going to figure out which property you're using. Like Marcel explained earlier, whether it's the property rule, the quotient rule, or the power rule. After you figure out that property and you apply the property, you're going to end up with a composite function. And like we learned before, when doing composite functions, you're going to use the chain rule. After you do the chain rule, you're going to have your answer, and then, yeah.
And I bet you're at home right now wondering, well, when do I use logarithmic differentiations? Well, I'll tell you. Logarithmic differentiations are used for more complex problems when the usual formulas that you use to solve differentiations they can't apply to the problem. You'll use it.
Right. So here's an example problem. So we are asked to find dy dx for y equals the quantity x plus 2 squared times x squared plus 2x minus 1 cubed over x plus 3 to the 4th power, and all of this is raised to the 6th power. So what we're going to do, we're going to have to take the natural log for both sides. Just like this. And so we're going to apply the power rule, which is log base b m to the n power, and then we're going to bring n to the front, then log base b m. So we're going to bring that 6 to the front. And it should look something like this. So after applying the power rule, we are now going to break up the argument within the brackets. So and it should look like this. And so what we observed from the product, from the problem being broken down into the arguments, we can see that there is a plus here because this was being multiplied on the top, so it's a plus. So I'm going to circle that. And then on the bottom, it was being divided, so it's going to be a minus sign. So there, the power rule, it applies here. So x plus 2 was raised to the second power. So now 2 ln is right here. So the exponents are brought to the front due to the power rule. So the left side is going to be implicit differentiation. And with implicit differentiation, you're going to be solving for dy dx. And so on the right side, we're going to be doing the natural log derivative and also the chain rule. So here you have the 6 out in front. That's just in the front. It's just a constant. And so ln, the natural log of the derivative of the natural log is 1 over y. So that's just going to be 2 over x plus 2, and then 3 over x squared plus 2x minus 1, and then subtracted by 4 over x plus 3. And so you have to multiply the y over to the right side, and so we know that y equals x plus 2 squared, x squared plus 2x minus 1 cubed over x plus 3 to the 4th power, and all that raised to the 6th power. So we're just going to multiply what we have by y, and that's how you get the answer.